Hello, let's do the New York Times Hard Sudoku for January 31st, 2024, last one of the month. There's a link in the description if you'd like to try it yourself, and I'm going to get started right now. All right, and we're starting immediately with the New York Times trick here, just in the top left. So what is the New York Times trick slash geometry slash just hidden triple, however you want to think about it. In this case, there's two ways you could see it, either a hidden triple in this row or a hidden triple in this box. I tend to find the one in the row first, just because of the way I scan boxes. But what we found here is that 4, 6, and 8 are in this box. They're given in this box, you can see that. And they are not, none of them touch row 1. So the question that we can ask ourselves is, where do 4, 6, and 8 go in row 1? Because we need 3 open cells for it. They are not already placed in it, and they cannot repeat in the box. So that leaves exactly 3 open places for the 4, 6, and 8. So that is where they go. So we can just immediately put 4, 6, 8 here. Now, one thing we'll notice before we even put 4, 6, 8 here is that the 4 can't go here. So the 4 ends up here only, because the 4 needs to go in one of these 3, and it can't go in these 2. So it definitely goes here. And then we're left with a 6, 8 pair here. Additionally, you could see that instead, you could see that 2, 5, and 7 need to go in this box somewhere, and there are only 3 places for 2, 5, and 7. So this is where 2, 5, 7 goes. And you can see that this cell here sees a 5 and a 7. In fact, the 5 is only one place to go. And then this can't be 7, so this is the 2 and this is the 7. Now we're left with a triple. You could have also just, when you filled this 4, 6, 8, you could have just filled this triple. Also, you could have just seen that this was a naked triple and gotten both of these from that. So there's lots of ways to see that, but I find that, you know, if you aren't sitting here explaining it to a bunch of people, if you glance at 4, 6, 8, you glance at row 1, you go, that's 4, 6, 8. And then you just take these 3 and bring them back in. It's very fast compared to having penciled these 3 and seeing that they were a triple. So anyway, this is the remaining digits. This is 1, 5, and 9. Just taking a quick glance below. Not 5. I missed something. 1, 3, and 9. So these 3s look up, right? So the 3 can only go there. And then, I was seeing this 9, but that's not helpful. So yeah, there's a 1, 9 left. It's already a huge head start on this puzzle, though. So we need a 7 in this box. These 2 7s look up. This 7 looks in. So that's the 7. 2, 4, 5, 7. So I've got this 6 and this 8 that need to go in this box. So they go down here somewhere. That means these are quite limited, right? Because there are 5, we can just do the math in our head, right? Counting. There are 5 open cells. So at most, these could have 5 possible digits, which is a lot. But we can subtract the 6 and 8 from them because we know the 6 and 8 don't go here. And the row needs them because we have them marked over here. So it's actually going to be 3 digits max. And we're going to find that, for example, this cell sees a 9, right? And this cell sees a 9. So actually, what we can do is we can say, where does the 9 go in this row? The 9 goes over here with the 6 and the 8. So this is going to end up being a 6, 8, 9 triple because we need 3 slots for 6, 8, and 9, and they can only go there. That's fun. And then now we're left with a pair here. We're left with a 1 and a 3, which is not resolved. This is also a pair for the box. We need a 2 and a 9. So this 9 tells us the order. That's 2, that's 9. It told us the order, and then I ignored it. That's 2, that's 9. And then over here, we need a 1 and a 3. Okay, so we got some 1, 3 pairs going on here. Cool. All right, so this top band is basically done. It just needs some stuff poking in to help finish off these cells here, but we don't really have to pay too much attention to that right now. So we're going to move on to the next band. Believe it or not, we only have done 1 band yet out of 6. Well, 3 bands and 3 stacks. But this 8, 6, 3, 7, I'm trying to see. Okay, well, the 6. So we already have the 3, 7, and 8 placed, but I am seeing that the 6 can only go in one of these 2. So that seems helpful. We've got these 2 7s looking in, and this 7 looks down. So 7's in one of these 2. How about 4, 5, 9? So what I'm looking at is I'm looking at 4, 5, 9 in this row, and I'm looking at 4, 5, 9 in this column. So this row, what I'm noticing immediately is it's probably not helpful, but we can take a look, is that there are 5 open spots for 4, 5, 9, which is a lot. Now I'm just looking to see if there happens to be a lot of 4, 5, 9s in the grid looking in. There's not, so we're not going to find anything there. What I'm noticing about this column is that we already have the 4 and 9 placed, so we only care about the 5. And these two 5s looking down would tell us the same thing, but there's a 5 in one of these two for the column. That in the terms of this column, 5 can only go down there. And then this 2, 7, of course, I'm looking and I'm seeing there's already a 2, 7 there. And over here, lots of opportunities to place 2 and 7. Not here, surprisingly, or not surprisingly, but interestingly. Actually, this one can't be 2, 7 either. Yeah, we know the 7's limited to these two. If the 2 were also limited to these two, meaning it was just taken out of this cell, then we get a hidden 2, 7 pair, but we don't have it. Let's see, what else do we have? The 6 looking in. No. I'm looking for anything else to do here. I was looking for something that might look into here, because that would get limited to 2 spots, but I don't see it. I'm seeing the 5 look in, but that's no good. Okay, I'm not sure there's much else to find in this band. That's okay, we'll move on. So this is something I haven't talked about. It doesn't come up a whole lot in Classic. It's really, really awesome to use in Variants. But let's talk about what's called roping. So let's look at this 3, 8, 9 here. Where do 3, 8, 9 go in this box and this box, right? Now, one option is that this ends up an 8, right? It doesn't actually end up an 8, and I can actually prove that it's not an 8, which is what's cool about roping. But I think one of the reasons I don't talk about roping much is because you can always just do it with just finding triples or things like that. Triples and pointing will get you the same thing. But it's a nice holistic way of looking at the grid, and I'm all for finding more ways to spot things. So if this was an 8, then all 3, whatever green is, all 3 green cells are also here. So then now we would ask, where does green go in this box? And the answer would be, it can't repeat in this row, can't repeat in this row, so green would repeat in this row. Now you can already see that this can't happen. We can't have green here, and green here, because this is saying green is 3, 8, 9. This is saying green is 3, 9, and something. I just filled an 8 there, but it's 3, 9, and something. But this is saying that there's a 1 involved, right? So if this something were an 8, this would be saying, hey, I need 3, 8, 9. This would be saying, hey, I need 3, 8, 9. But this would be saying, hey, I also need a 1. So there wouldn't be room for it. So an 8 would actually break the puzzle. Another way to see that this 8 breaks the puzzle is that we actually have a hidden 3, 9 over here, right? This needs to be 3, 9. And so if I put an 8 here, then there'd be nowhere to put 8 in this box, because this 8 would look in, this 8 would look in, right? But we don't have to worry about that hidden 3, 9 yet. We're going to get that for free because that's one option. Now, if that option actually happened, pretend this one's an 8 and we get a 3, 9, 8 here. Now we can think, so if this situation happens, all you need is the same 3 digits repeated in a row in 2 different boxes. If you can prove that, then that means it does duplicate into the 3rd box, but it also means that whatever these 3 digits are, let's call them purple, we can then ask, where does purple go in this box? Well, it can't be in the same row. So again, we're just saying purple is the set of 3 digits that happen to end up here, right? Then purple would go here. And then we would ask, where does purple go in this box? And it would go here. And then our final 3 triples are going to be the same 3 digits. We could call that blue. So this is why it's called roping, because it kind of looks like an intertwined rope. And this is one thing that can happen. You'll notice it did not happen here, right? It actually, for some reason, I guess it's more likely for it to not happen. But anyway, when it does happen, it's a really nice shortcut because you know exactly what digits are going to appear in these locations. There's one other way this could resolve, which is to swap these 2 boxes. So this middle one would end up here and then down here instead. So there's 2 roping patterns that are actually roping. There are also 2 patterns that are the sort of unroped, the non-roped pattern. That's what we have here. And the way to prove that is to say, well, I know that my 3 and my 9, so the only other case is to have 2 of the digits repeat. You don't know necessarily which 2 are going to, but you can't ever have 1 of each. Let me show you what happens if I were to say, I've got 1 of each here that end up here, and then wait, how do I do it, right? How do I get this to split up such that none of these are together in this box? And the answer is I can't. 2 of them will have to end up together because I can't make this blue. I'd have 4 blue digits in this row. So no matter how you try that, if I go, okay, well, how about if we just put blue down here then? Well, we could put purple or green up here, but then now the other one is going to have 4 in the row. So you're always going to have 2 digits. So let's actually inspect this finished band we have up here. Of 5, 6, and 8, which are the 2 that repeat in the other 2 bands? And the answer is it's the 6 and the 8. We have a 6, 8 here, 6, 8 here, and 6, 8 down here somewhere. In this row, what are the 2 that repeat? Is it going to be 1, 9? Is it going to be 1, 3? Is it going to be 3, 9? Well, we know that the 9 isn't with the 1, 3 down here, so it has to be the 1, 3. So yes, we have the 1, 3 here and the 1, 3 here. And there you go. 1 and 3 repeat. And then down here, is it going to be the 4 to 2, 4, the 2, 7, or the 4, 7? And the answer is the 4 is on its own. So it's got to be the 2. No, it's the 2, 4. There it is. It's the 2, 4. 2, 4, 2, 4, and 2, 4. So you're either going to have all 3 repeat or you're going to have 2 of them repeat, right? So this 3, 9 repeats down here. Now you can find out pretty quickly whether or not we're roped or not in this case, because first of all, we go, okay, where's green going to go up here? And by kind of noticing that these 2 are already repeating, we know that they've got to end up here, and 1 isn't either of them. So they end up here. This is 3, 9. And now we can expect the 3rd digit that goes with them, and 1 and 8 don't match. So we can know for certainty that this cell is not a 1 or an 8. And you'd be able to prove that by like going through and doing pointing and stuff like that. Like this 8 looks in, it's in one of these 3. This one looks into here, it's in one of these 3. And we've just proven that this isn't 1, 8, but you can just sort of know that naturally and go, okay, this one's not going to end up 1, 8. And that's why I never really talk about it that much, but I think it is a nice shortcut in certain cases. And I thought this was a really good example of it. So that's all I'll say about that right now. But we know that this one's not 1 or 8. We also know that it's not 2, 5, 7, 9. So let's see. It's not 1. It's not 2. It's not 3. It could be 4. It's not 5. It could be 6. It's not 7, 8, or 9. So it's down to 4, 6 only. So I thought that was interesting to talk about. I know that just ate into a ton of my time here, but I am not racing anybody. There's a 7 one of these 2. And if you want to know the generalized term, it's braid analysis. The only thing I've ever found on braid analysis is a really, really old website that talks about it and actually has some errors in it. But so yeah, it's not really used a whole lot beyond just sort of in Classic, beyond just sort of a nice oddity. And it can be used as a little shortcut. You may have noticed it happening already. But in variance, you can often recognize this and save yourself a huge amount of time because the clues are not necessarily as straightforward in variance. Anyway, I found these 7s here because these 2 7s look down. I think that's how I found those. I found it somehow. This cell's missing 1, 6, and 7 in addition to a bunch of digits. So actually, I'm going to think about this whole column. So we need 1, 4, 5, and 9. I'm actually not very happy about that. These just can't be 9. So these are from 1, 4, 5. Oh, that one's not a 1. Okay. This can be any of 1, 4, 5, 9. All right, that's not as exciting as I hoped. Let's see. Well, I guess the 4, 5 is kind of nice. Was there anything else here that I might have missed? 7 and 1. Actually, I need a 7 in this row. Whoa. I think I right-clicked and went inspect. I think that's what happened. Oops. You saw into the source code. Okay, so 7 in one of the is not there. This 7 says it's not there. These 2 7s say it's not there. So this row needs a 7. It goes there. That's pretty nice. This column needs a 1, 2, and 9. Oh, and this isn't 1 or 9, of course. Yeah, so this is the 2. Nice. It's also the only place in the column for a 2. That divergence into roping has really derailed my solve here, but that's okay. We'll get back on track. We need 1, 4, 5, 6 here. Sure, this is 4, 5, 6. This is any of them. All right. What else are we doing here? Was I finished scanning this? Let me make sure I finished scanning this band because that 7 was good. 1 we know is down here also. So 1 in this box is in one of these 3. That's important. Let's do a vertical scan now at this point. Yeah, we know this is 1, 4, 5, 9. Anything else to see here? I don't really think so. I think I did this stack pretty well. How about this stack? We got the 5s. So 4, 5, 9. Yeah, I already kind of scanned this too. There may not be more to find vertically, but we'll look over here as well. There are 2 2s looking down here. So that does put a 2 in one of these two. Remember, this was a hidden 3, 9, which is why this can't be 2. In fact, for this row, we need a 2, which is over here. No. The 2 already has a row. Never mind. The 2 already has a row. The row already has a 2, so never mind. We need a 2 in here, though. Yes. So 2 is not, this 2 looks down, this 2 looks in. So 2's in one of these two, which means this can't be a 2, or there'd be nowhere to put 2 in this box. So that ends up a 2. Okay. Let's see here. What does that 2 do for me is really the question I'm asking myself. I'm thinking there's something going on with this row. So what are the digits left? Because we have 3, 9 known. So 1, 2, 3. We do need 4 and 5. And 6. We need 4, 5, 6, 7, 8. So this can be 4, can't be 5, could be 6, can't be 7, could be 8. Okay. So these are what? 1, 3, 4, 6, 8? So this is 1, 4, 6. This is 1, 3, 4, 8. It's not 4 or 6. So this is 1, 3, 8. This feels so close to just cracking. Okay, so I want to look at more restricted cells. I guess that's what I already started doing, kind of naturally. But now I'm officially doing restricted cells. So what else is restricted in this grid? How about this column? Ooh, there's like 5 left in all these. But let's take a look. So we need 1, 2, 6, 7, 8, 9. Wait, 1, 2, 6, 7, 8. Yeah, no 9. 1, 2, 6, 7, 8. This isn't 2 or 7. So this is 1, 2. Oh, it's sorry, not 2. 1, 6, 8. I need water now at this point. 1, 2, 6, 7, 8. This one's not 7, 8. So this is 1, 2, 6. Is there something with? Oh, there is something with 6s. 6 in this column can only go in these 3. There's another way to see that, which is 6 in this box is here and 6 in this box is here. They're just not in this column. So if you saw that lining up, good job. I didn't see it. This 6 looking in did that. So anyway, 6 is down here, which means it cannot be in any of these cells because otherwise there'd be nowhere to put 6 in this column. So this cannot be a 6, which we had marked as a 6. So that means 6 in this column is exactly here. Right? Because that's kind of crazy how that worked out. Is that even true? No, it can be up here. Yeah, I was like, how did that happen? It didn't. The answer is it didn't happen. Yeah, sorry. Just didn't look at the top of the grid. I was one of those, wait, how does that work? That shouldn't have worked that way. And then you look and go, oh, I was just looking at puzzle wrong. Okay. We also know that these 4s are looking down. So 4 joins the 6. That's like almost interesting. Almost a triple. But we see that from this being almost a 1-3 pair also. It's the same deal. It's the other side of the coin. So if these not being 6, is that helpful? That is actually helpful for this row. Almost. There's 2 places. Darn. Okay. Well, let's think about this row again. So because we know 6 is excluded from these 2 at least. There can't be 1, 2, 3. They can't be 4. Both of them see a 4. 5 could go here. Can't be 6. Could be 7. Could be 8. Okay. I mean, these are all nice, but they don't link up to anything. Can this only be 1, 2, 5? Is that? It can't be 3, 4. Can't be 6, 7, 8, 9. Yeah, this is only 1, 2, 5. So my corner marks have kind of become center marks at this point. And it's because 8 is up here. Okay, so I don't think should I keep I don't think I should keep the corner marks. I think it's much cleaner if I just leave that penciled like that. That didn't help though. That's unfortunate. How about this column? So I need 3, 4, 6, 8, 9. Well, this can't be 3, 8, or 9. So 4 and 6 only. Ooh, almost. 3, 4, 6, 8, 9, not 3. So 4, 6, 8. It's not 9 either. Yeah, this 3, 9 pair takes 3, 9 out of these. Oh, well, that's nice. This 3, 9 pair tells us, hey, oh no, 9 can be up here, but 3 is placed. That's actually nice. So I keep missing. I'm sorry about that. I'm catching it though. So 3, 9, where do they go in this column? Well, 9 can go in 2 places, but if we look, where does the 3 go? It only goes here because this 3 sees in. So once we place the 3, now there's only one place for 9, which goes up here because this 9 sees here. So definitely double checking, but yes, this is the only place for 9 in the column. Okay. Now this 3 gave me a 1, 8 here. Does that help me? Unfortunately, it does not, because it didn't make this a pair. But it does place 3 in this box though, which is helpful. So that's 3, that's 1, that's 3. This is not a 1. In fact, 3 in the column was placed also. Okay, I missed that. What can I do here? I'm thinking about the rest of this box, but I'm also thinking about this stuff I just got being helpful. We're going to do 4 and 6 for down here. So yeah, let's just look at this box. We need a 4, 5, 6, and 8. This one's not 4 or 8, so this is only 5, 6. This can be any of 4, 5, 6, 8. Okay. This column needs 4, 6, and 8. It's not 8. It's not 4. Oh, okay, so it's 6. That's 4, that's 8. That makes that 1, 6 only. Tell me that does something. 4 in this box is here. That's 5 or 6. This is 1, 4, 5, 6. Any of them? Okay, what are we doing here? This is 1, 4, 5, 9 still? Seems to be. How about this row? It's got 3 digits left. 1, 2, and 5. Oh, so this can't be the 1 or the 5 from the box. There we go. So that's the 2. These are not 2s. This 2 looks down, so we get the 5. We get the 6, we get the 1 and the 2. We get the 8 here. These are not 8s. That's not a 5. 7, 8 pair, 4, 6 pair. Okay, this is the 5. We get the 1, 3, 1, 8, 6. Now we're correct. That's not a 5. This is 9 and 3. That's a 5. That's not a 5. So 5 in this box only goes here. This is 1, 4, 6. Might as well write it out. Okay, take a step back. What do we need? This box looks promising. We need a 4, 5, 8, 9. So the 8 is placed. 4 is placed. 5 is placed and 9 is placed. Nice. So that's 1 and 6. That's 8 and 6. That's 9 and 1. That's a 7 and an 8. That's a 7. We get the 4 here. We get the 6 and the 4 here. The 6 and the 1 here. This cell is a 1 only. And then this cell is a 4. And then down here we need 2 and 9, which go in that order. All right. Well, obviously it took me a while because I spent quite a bit of time explaining the roping, but hopefully that was interesting for you. If we take a look, we had this original 3, 9 here that ended up here. So what are the 2 that repeat here and here, right? So it would be the 2 and the 5 here, would be kind of our purple digits that repeat. And then we've got the 7 and the 4 here would be our blue digits that repeat. And then the 1, 6, and 8 are free agents that sort of flip around, right? So, and in fact, if you think about it, they're going to be 1 per row, right? So they're going to rotate in some way. We can call those the gray ones, the free agents. Maybe I'll use a lighter gray here. And so we could identify that in every single band stack and stack, but I'm not going to sit here and do that. But I thought that might interest you. Now, do we have any actual ropes? Not here, not here. This one here. This 1, 4, 8. As soon as you see 2 of them rope, like 1, 4, 8 here, you know the entire stack is roped. So 2, 3, 6, 2, 3, 6, 2, 3, 6, and 5, 7, 9, 5, 7, 9, 5, 7, 9. So that's what I mean by roped versus braided. So I hope that was interesting for you. It's going to be true of any solved Sudoku. It's going to be those two potential patterns. And so, yeah, hope you enjoyed this. And if you did, why not leave a like, subscribe, and a kind comment below.